Well, hello again. I'm going to have to replace this resistor here also. It's a 50K, which is green, black, and orange. You know, a body, end, dot. Green is 5, black is 0, and orange is 3 zeros. So 50K, and it's on the mixer tube again. And I've got to get it replaced. It looks good. It's a nice looking resistor. However, it's measuring almost 62K. So it's got to go. Got to go. Every time I turn around and find another resistor, I remeasure it, double check it, and I say, I better get rid of it. It would probably work, but I need to get rid of it. It's gonna be a toughie, boy, getting down into that mess, getting that stuff cut out. But it shall be done. Then we will remove, like I said in the last video, this one, and this one. The band, this solder joint right here, coming through that band, if I suck that solder out, you'll see probably a couple of wires down in there. Those two wires would be the wires that come out from each end, okay? Each of these. And what they did, they just joined them together and then they hooked the two wires to ground. Because as you'll see, these bands right here, I don't know why I'm having such trouble with this light here. It's very bright today. This band right here is attached to ground right there. Each one of these bands is attached to ground. That one's attached to ground. This one over here on this one is attached to this ground right here. And the other one, the final one, the band, which is down in here, you can barely see part of it right there. That band right there is attached to this ground right here, which they're all grounded to the chassis. And then they just ran the other end of the leads out to where they had to go. You know, this one went this away, and this one went this away down here, and you know, so on and so forth. So that's what we're going to be taking out, and they're going to be easy to change. All I have to do is wherever this one goes here on this one, and wherever it goes on the opposite end, I just need to attach the new replacement capacitors to those points, and then find a nice grounding point for the opposite ends. I can do that for each of these. All right, wherever this one here, for instance, will go. I'll attach one end of the 0.1 cap replacement there. The other one will go here. The other one will go here because it comes out and goes here. Then I got to find a plate replacement point for the grounds. And see, this right here is an isolated terminal. This one right here, at this point right here, and this point right here, they're not joined together. They look like they are, but they're not. I'll connect it up with the multimeter and show you. I have the multimeter connected, and I connected it to the chassis, so you can see we do have continuity. And that continuity is between this ground point right here, where I have the red one connected, okay, right there. Now let's connect it up here at the top and see if we have any continuity there. And look, you know, when you take a look at this terminal strip, initially you see that these are two to the same point. No, they're not. If you look on the back, you'll find out they're separate. That was one of the reasons I talked to you earlier about isolated versus non-isolated terminal strips. Now you see why they use them, what they use them for, rather. And as you can see, there's no continuity. Now, there's more than one way I can do this. Hooking up one end of the capacitors to where they're supposed to go on the different points, that has to be done. But as far as the grounding goes, there's several ways I can do this. I can twist the two together and find a grounding point somewhere close by, and connect a length of wire from where I twisted them together to that grounding point. You know, a little short length, wherever I can find the nearest ground. That's one way of doing it. Another way of doing it is to put a terminal strip, such as this one right here. This will probably have to be cut down a little bit. Let me get rid of some of this crap. See, now what we have here, we have a non-isolated terminal strip, the one I showed you earlier. I could cut this right here with my moto tool, which would shorten it up, giving me enough, it would be short enough to fit down in here. I could use one of these holes with a screw, and then I could run a wire from both of these sets of grounds to that terminal strip. That would probably work. This one here, Who knows, I might be able to somehow get it to fit on this grounding point here, or I could use it over here on this grounding point, use the wires from the other end. You'll see. Piece of cake, really. Now here's another example of why I like to use the coil method. I call it the coil method of soldering. This is a very tight spot to get your iron in, and they wrap a lead around or whatever it is you want to do. Whereas if you just snip out the resistor, leave yourself a stub, make a couple of coils, slip them over, and it holds itself right in place while you solder. It doesn't matter how tight it is. Sometimes it takes a little while to get that thing, those coils over those stubs. But once you do, it'll hold it right in place. Alright, with that done, I want to go to my hardest, or the hardest one to remove first. Once I get over that hump, the rest is easy. So all I got to do is snip it loose on both ends, here and here. And first I want to make sure I know where the lead goes. Well, the first one came out real easy. I'm kind of glad. I got to go downtown here in a few minutes, but you'll see where the I want to focus in and I want to kind of show you these. You may not ever see one of these. Again, this may be the only time. They're not, you just don't see them that often. This is only the second time in all the years I've been working on radio. See where the negative lead came out right there? And on the other side is where the other one came out, but it broke off. The piece of it is still sticking out of the bottom right there. See it? Right there. We're soldered in. Anyway, the way I got this thing off on the back, as I thought, they're real soft aluminum. I cut through them horizontally. It's the only way you can. I cut through them horizontally this way, 2 or 3 attempts, and it finally cut through. And then I was able to push both ends. It was attached to the bottom too, which really made it a problem, but I managed to get it off there by prying this thing around. Broke it off. And then, let me back up here a little bit so we get a little more view. I just took this right here, and I remember doing it now with the first radio. It was like this. This was around like so. I just got a hold of it with my long needle nose on the back here, because the cap was already out. This was just attached to the rear of the grounding point. And I just kept flexing it back and forth like this, back and forth. It took a while. My wrist got a little bit tired, but finally it popped right off. So that's how we got that baby out. Now the question is, we can get the new capacitors in there easy to hook here and to hook to this thing right here sticking out in the wind. Okay? But then we have to deal with the grounds. I think, I'm kind of hoping that, see, there's an open hole right here where the ground is. No, sorry, wrong one. Right here, where the ground is. Alright? Now the question is, will 2 of these leads fit through that hole? If 2 of them will fit through the hole, let me get a little clarity here, sorry about that. If 2 of them will fit through that hole, I can attach one end of the capacitor here, one end of the capacitor here, run the 2 ground leads through here, which is grounded to the chassis, and I can solder them up. So let's find out if those 2 leads are going to fit through that hole, if 2 of these capacitor leads will. If not, we'll have to come up with something else. Voila, look at there. Fit perfectly. So now I know where the ground is for this one. I may wind up making it the same ground with the other ones. When I get back from downtown, I'll see what I can do about getting this thing in. Or both of these things in. Well, that's the way this first one went down. We did pretty good. I brought the leads through all the little holes. Instead of, and then when I got them through, I bent them up just a little bit. They wouldn't solder to these brass rivets for some reason. I don't know what the deal was, so I had to bend them up and solder them to the existing piece of solder right here. So that looks pretty good down in there. Now they can see what the value is and everything. Which is another thing I should have pointed out a long time ago. When you put your capacitors in, when you're done soldering, you should be able to see every single value. This radio here had them turned every which way. I had to spin them around to try to figure out what they said. Don't do that. Solder them in so you can see the value on every single one. It's facing you from the chassis. So this one's done. Let's move over to this one, and then I'll finish this one, and then we'll put a new power cord that I got. I got a smaller, not so thick and heavy power cord for it today. While I was downtown, I bought one of those dollar, flea market jobs. You betcha. And now we can go ahead and, once we get that done, put the cord on and power it up. See if we get some noise. Okay, folks, the deed is done. I used an existing hole. Let me get down in there for my ground on this set right here. And it was originally grounded with this tab underneath this screw, but over here was a tab that stuck out, had a hole in it. I just slid them through there and soldered them up for my ground. These here, I just went ahead and soldered them to the existing ground, stuck one over there, and one right up to there, which is not the ground, and that took care of it all. Here's our boneyard, 11 capacitors all total and 5 resistors. 6 resistors. I haven't changed these 3 out, but I probably will. I think I've already mentioned that. They are within tolerance, and so is this one. Matter of fact, they're surprisingly close. But I don't like those dog bones. I'm going to get rid of them. And then this 100K over here. I thought it was a 1 meg to begin with, but it's not. I went back and looked at the schematic and studied it a little bit more. This is turns out this is 100K. It's R3. So, guess what? It's time to get rid of this junk in the trash and turn this thing over, put a tube in it, and let's fire it up and see what happens. Alright people, we're ready to go. Now I'm going to treat this as if this was the very first startup. Just because we fixed everything under there, you don't want to be just cranking it up to 120 volts and see what happens. You never know, you could have made a mistake. I could have made a mistake, another mistake, and another mistake. You never know. Until you see this thing performing the way it's supposed to perform, you always have to assume there's been a mistake made by you, or the guy before you might have rewired something wrong and you haven't caught it. So let's go ahead and put a little fire and hole. A little bit of variac action. Now let's watch our voltage over here. Oh, that turned the radio on. I guess that would help. Let me move this over here a little bit. I'll tell you what the voltage is as we come up. Got 30, 50. And we are getting a light lit. How about that? God, I hope this thing tunes in a couple of stations just like normal. A lot of work's been done to it. The worst thing in the world is to do all this kind of work on a larger chassis and then fire it up and nothing happens, or it just doesn't work. And it's like, oh, back to the big drawing board, you know. But you got to stay with it. It's all part of the hobby. All right. Not doing too bad on our amps are good. That's what I always worry about, the amps more than the voltage. Okay, we're doing pretty good. We are up to 80 volts. All right. Our current draw is still pretty good. We're going up to 110. Well, we're getting some good sound out of it. Our current draw is much lower than it was. Remember that? All those old nasty leaky caps helped out a lot. Fantastic. Alright, let's go on up to 120 now. Alright, we're about 121 right now. I don't know what all that static is. I hope it's not a bunch of stuff under there burning up. Alright, let's tune her in and see what happens.
From the cathedrals right there, some great playing right there from the trumpet.
Are you serious? Woohoo! Picking up stations, good. How about a little Jackie Gleason music here? Like I have it on my my transmitter. The static you hear is in fact a small storm in the area. I love Jackie Gleason music. Capitol Records. for you young guys, that's not Jackie Gleason playing that trumpet. He produced these albums. He did about 55 of them. He's passed away now, but he had a Jackie Gleason band. He never played in it. He was a comedian, and he produced 55 of those records, those albums. And I've got about 4 or 5 of them. They are so good. Oh, it makes me want to go to sleep. They should have put a bigger speaker in this radio. Of course, once it gets in, it'll be anchored to the cabinet. A lot more vibration going. It'll sound a whole lot better. I have to clean this up a little bit too. We'll do that when we do the cabinet. I think we can call this one, as far as the chassis goes, finished, I think. I was going to paint this. I have a clear orange. I was going to paint that orange, but then when I got thinking about it, I said, I don't know, maybe that would darken up the dial too dark. Maybe we should just leave it like it is. Picking up stations real good. Lots of static, of course, with AM. I don't know where it's coming from. Somewhere around here. Probably my computer in back of me. I think what I'll do is I'll do what Buzz does on his channel sometimes. He does an experiment. So we'll call this John's experiment. I had read years ago on the Antique Radio Forum that some people, they had stuck on-off switches, or they had volume controls that just were doing the same thing this one was doing. And what they did was they drilled a hole, they drilled a small hole in here, you know, off to the side, and they were able to spray cleaner down in there and then work it, and actually the switch started working. I've seen that. And a couple of them even got their volume control to go. They spray cleaner down in there and just work it. Yeah, I think if I remember right, they had to drill 2 holes, one here and one to blow out when they got done. I can't remember. I think what I'm going to do is that you don't want to be drilling it to here. Out here is where the wire round resistor is, which is probably what that is. It seems to me they drilled somewhere like down in here someplace, away from that resistor, and then sprayed it. I'm going to give that a try. It's worth a shot. I mean, it's already no good, so what the heck? Let's try it. Alright, I drilled a hole, got it all the way through. It was a slow drill, very slow. I didn't rush it or anything. Just drilled it all the way down through. Now I'll tell you what, let's just go ahead and squirt some stuff down there, see if it has any effect. I sprayed her out, and I'm going to let her dry for a little while longer, but only one side of the pot is working. This side right here. After it dries out, the other side may work, but even the side that's working is no good. It's supposed to be a 500K pot. It's over a meg. So I'm on the 2 meg scale, so you can see. And once, if I go a little bit further, it goes totally dead. Let me hook up the other side. Maybe it's come back to life too. You never know. A little bit of this thing might have dried out a little bit. Yeah, she's up there too. Look at that. We're almost up to 2 megs. This is our shortwave band. It's 2.4 megacycles up to 7. It looks like about 8. And then it picks up at 8 and moves down to about 18. So this is the smaller. What do they call it here? They call this the shortwave, and they call this the intermediate shortwave. And then of course we have the broadcast band. So we're getting something on that. Not much coming in on the intermediate. Maybe I need to work on that a little bit more. If I can just get something in, I can tune the oscillator a little bit. I'll have to work on that. There's one aspect about this radio that I really like, and that's these trimmer caps. This is the antenna section. This is the oscillator section for the 3 bands. This is the broadcast, intermediate, and what they call the shortwave, and shortwave. So it's I don't know why they use those terms, but I'm sure there's a reason for it. But they're right across from each other. I thought that was pretty slick. And easy to, you can tweak your oscillator, or tweak your antenna, then do your oscillator, antenna, oscillator, antenna, oscillator, and it brings your stations in a lot better. I also went ahead and put some plastic underneath this capacitor instead of cardboard. I had some leftover plastic from another project, and I cut a piece and super glued it down in there. It'll stay. All right, that's going to be the end of this one. I can't do much more. It didn't cost a whole lot to do this. I paid $1 for a new electrical cord, a polarized cord at the flea market. It was brand new, still in the package actually, for $1. I took that one. And then I bought some capacitors for it, but I had to do those anyway. I was really low. And I already had the spray paint and a couple of resistors. Already had those. So it didn't really cost a whole lot to do this. I already had the wire. Can't think of anything else. The tubes had all checked out good. I did not have to change those because this was an operational radio when I first fired it up. So that's about it. The only thing I have left to do, and I'll do that in a little while. You'll notice that this part of this is about the same length as the other one, but if it's not, I'm going to cut it down with my moto tool. And then I'm going to shave a little bit off to kind of make a flat spot, because these knobs require a flat spot. See if I can get this thing off here to show you. Yeah, this requires a flat spot right here. So it's going to have to be shaved down a little bit. And right here is where you really run into problems. People always cut it down too much. Just a touch at a time. Touch. Test, put your knob on. If it fits fine, should fit nice and snug. Or if not, just barely take a little off. I can't tell you how many shafts I've screwed up doing that, and I had to wind up putting a load of solder on there, heating it up, putting solder on, then shave the solder down. I learned my lesson the hard way about 3 times. Now I'll bend these tabs out just a little bit too. And one more thing. I keep saying there's one more thing. I'm trying to cover everything before I end this series and move on to the cabinet. A lot of people will take these and bend them completely over when they've already straightened them out to get the dial off. Not necessary. Just take 2 of them and bend them just barely. Or if you want to bend all 4, you can just bend them barely so it doesn't come off. You don't have to flatten it on down. You're asking for them to break off when you do that. Just barely enough to keep the dial on. That's all you need. Well, guess what? As you can see, I just barely bent these things just a touch to keep the scale from coming off. And this one here, when I got done, I took the flat billet pliers, I just barely moved it. I mean, I almost didn't move them at all, just barely. And when I got done, I looked at it and it looked kind of screwy. I said, man, that one doesn't look too good. So I touched it with my finger and it fell right off. So it had probably almost all the way broke through when I straightened them out. It's going to happen. We don't cry over spilled milk. I still have 3 of them holding it on. It's not going to go anywhere. Try not to use super glue and all this other crap on them. You know, it's not like these scales are a dime a dozen. You can have one made if you send it into Radio Days, I guess. Cost a fortune, but try not to do that. And that's not going to go anywhere. It's on there nice and secure. I guess that's it. The cabinet's next. Until next time, this is John.